Okay, look up here. The review for the thermodynamics test. Here it is. This is the test. Okay, looks ridiculously short because you're not going to write any of your answers on the test because you're going to have a separate piece of paper for all your answers. There's only 10 questions. There are only 10 questions, and the questions are all problems, pretty much, with the exception of is this endo or exothermic, spontaneous or not, stuff like that. No short answers. All right. These represent all the kind of questions, but they're not complete. For example, when it comes to this guy right here, I will have separate questions on just solving for delta H or just solving for delta S. All right. And then I'll also have you do the delta G both ways, delta H minus T delta S and products minus reactants. So it's not everything on here. And let's not forget number 7, which I won't do on the board today, but may just mention a little bit about, is also on there. That's the section you did on your own. All right, let's get started. Let's do these first two. As I do these, I'm going to try to point out all the mistakes you made. We saw some new ones and even made some new ones today. First off, this guy is so long ago we may have forgotten. I'm not looking in the back of the book for this. I'm just using this equation. Oh, you're kidding me. No, I really don't need this. This is ridiculous. Oh, we're doing a projection. Well, it's you guys who aren't going to get the review if this manages to screw up.
Technology.
Well, hopefully it's going to hold here. Delta H equals MC delta T. All right? That's the equation. We haven't used that for a while. We've been using the ones in the back of the book, Appendix K. All right? Well, what are the mistakes we might make here? Not many. This is a pretty easy equation. Your mass in this problem is 20 grams. Your specific heat for water, it doesn't tell it to you, but you should know water. Just use the easy one, 1 calorie per gram degree Celsius. And your temperature change, the one thing you have to remember is TF minus TI in order to get the correct sign. And therefore, it's the final temperature is what, 40 degrees Celsius minus 75 degrees Celsius. And there, you do all the math for that. What do you get?
So I got negative 700 calories.
Negative how much?
700.
Negative 700 calories. All right, with a decimal point because of 3 significant figures, I suppose. Remember, this guy doesn't limit you. Now, that's not the end. That's how many calories there are. It asks also for joules, so you'd have to do a conversion. Calories on the bottom, joules on the top. 1 calorie contains 4.184 joules. And when you do that math, what do you get?
Negative 2,900.
Negative 2,000?
928.
All right, so negative 2,930 for significant figures. Again, it's 3 significant figures, okay? I wouldn't care if you left 2028. I mean, it's going to be, most points you're going to lose in this test, maybe 1 or 2 total for significant figures. You did nothing right, okay? And I'll be generous about certain things, like in this one. Anyway, I want to go to that. So, good enough. Is this endo or exothermic? Exothermic. Would it be favor spontaneity or not?
Yes.
Yes. Would it release or absorb energy?
Release.
Release. And feel hot or cold?
Hot.
Okay, most likely. I mean, not always. All right, now, let's do the next one. Fahrenheit to Celsius. Give me the equation, Lizzie, for Fahrenheit, to get Fahrenheit from Celsius.
9/5 times degrees Celsius.
9/5 degrees Celsius plus 32.
You know,
Okay.
it's weird. You asked me that question. I sat in the same seat this morning.
Very nice. Look here. I would recommend just memorizing one of the 2 equations so you don't accidentally throw parentheses in where they don't belong, but you can always rearrange it to solve for the other guy, right? That's an easy calculation. I mean, I'm not going to show the numbers for it. What do you get for that answer? Because there's a mistake I want to point out to you. What do you get for this?
Negative 11.
11 point, or just 11? Well, no, it's just 11 because there's only 2 significant figures in that one. All right, now, negative 11 degrees Fahrenheit. Here's a mistake we made very quickly earlier, okay? We have to convert that to Kelvin. And if you're not paying attention, you'll go and add 273 onto that one. Is that right? No. You have to add the 273 onto the Celsius temperature. Negative 24 degrees Celsius plus 273 gives you, what, 249 Kelvin. Okay? So there will be only one probably of those where you're solving for Celsius to Kelvin and from Fahrenheit to Celsius.
At least one.
Okay. Well, only if you memorize the equation correctly. All right. The molar enthalpy information equation is really very easy, but a lot of people will leave this blank or do something really stupid on this. Let me show you what. All I have to do in this one, because people are like, I don't understand, what does he want in this one? I want you to write, this guy formed from his constituent elements in their standard states. So what's the standard state for carbon? CS graphite, right? And the standard state for hydrogen is H2. He's diatomic. You got to look these guys up in the right columns where the delta H is 0. And then you get C2H4 gas. Okay? Now, so that's one little thing. The next thing is I got to balance them out correctly. I need 2 carbons over here, and I need 2 in front of that hydrogen over there in order to give me the right subscripts over here and the right number of atoms on both sides. But it will happen. It may happen on a test. You may even have to use a fractional coefficient in these kind of problems. Why?
Make them equal.
No, just to make them equal, but for another reason. Like normally I would not use a fraction. Why would I use a fraction in this case? Because this always has to be a 1 in front of it. All right? For example, to say I was making water, and I was making it from a standard state element, H2 plus O2 yields water. Normally you would balance that by doing this. You would normally say, okay, well I got 2 in front of that guy, and then a 2 in front of that guy. You can't do that if I want the molar enthalpy of formation equation because the number has to be a 1 here. So how would you actually balance that guy? Yeah, I would actually have a half of an oxygen. Okay? So that's another little problem. And the last problem is when you look up the delta H at the back of the book, what is it? What's his number in the back of the book for this guy? Because that's not done. That's the equation, but it doesn't have the energy.
52.26.
52.26. But is it positive or negative?
Positive.
Positive means it's going to go on this side. And so you'd have to put somewhere in there plus 52.26 kilojoules. You see? All right? Not on the other side. That would mean it was given off. This means it's being absorbed. So there's your mistakes you can make on that one. All right, hopefully you won't. Now, let's go to this one. This guy is going to be a long one. And there will be one like this on the test. It's going to ask you to do it both ways. The delta H by C delta S and the delta G, products minus reactants. But I'm telling you, there's also going to be on a test, because you notice you got the review done in less than a period. There'll be a separate one on delta H and a separate one on delta S. I will point out to you the 5 big mistakes people make on this. Let's do the delta H first. Delta H of the reaction equals delta H of the products minus delta H of the reactants. That is the general formula for most of these guys. All right, and we know why, because of Hess's law. Products. First mistake, reading from left to right and look at these guys up. They're not your products. The product is over there, 2 times water. 2 times water. What's water's value?
Maybe you're 285.
Anybody not get 285 point, what is it, 8? If you didn't, here's the 2 reasons why. Here's your next 2 mistakes. Looking up the wrong state, liquid, solid, or gas. Looking in the wrong column. There are 3 columns back there. You got to look at the delta H column for this guy, delta S column for the next guy, and when you do the delta G's, you got to use that column. All right, and that's in kilojoules per mole. We're multiplying by moles. Okay, minus brackets. Now this is easy because if you look up both of these guys, they're both in their standard state, so it will be 2 times 0 plus 0. Obviously, you don't really need to do anything there, right? It'd be nice if you showed me all this work anyway, so I know what you're doing, and if you make a mistake, I can find it and not take off as many points. All right. So what do you get when you multiply that guy out? Negative what?
571.6.
Okay, and that's in kilojoules. Okay, negative 571.6 kilojoules. Now I also have to look up delta S.
Delta H.
Right. Let me just use a different color anyway. Keep it straight here. All right. So delta S of the reaction equals what? Okay. Well, same exact equation. Delta S of the product minus delta S of the reactants. I look up that, and this time I'm not going to get any zeros because there's never a 0 for the number for delta S. Although the for the absolute entropes, but for the answer I could. Products minus reactants, 2 times waters. What's waters? Liquids, waters. 69 point what? All right. And that's in joules per mole Kelvin. That's kind of important for later. Minus brackets. 2 times hydrogen, which is what? 130.6 joules per mole Kelvin. And plus oxygen, which is what? 205.0 joules per mole Kelvin. Okay? Now, you're multiplying by coefficient, so you're taking care of the moles in that calculation. You do all the math for this. What do you get for your delta S?
83.62.
Anybody else get that? That's not the number I remember from last period. Negative?
Yeah,
326.4. All right. And that's in joules per Kelvin. Okay? Because we already took care of the moles. All right. Now I've got my delta H, and delta H says one thing. He says, I want you to be spontaneous. He says negative. Delta S normally, I mean not normally, but if he wants to be spontaneous, it's going to be positive. He's saying he's negative. So I have a fight here, and who's going to win is going to determine is going to be determined by the temperature. So let's take a look here. The final step, and I'll put it in red here, will be delta G equals delta H minus T delta S. Okay, what kind of stuff we have to do now? There's a mistake to be made yet. When I go to put this guy in, that's no problem. I've got delta H is minus 571.6 kilojoules. But minus, T is not a problem. Although some people will ask me, raise their hand tomorrow, I know they will, say, where is the temperature? You didn't give us the temperature. How am I supposed to do this? It's right there on the chart. What is it? 298.15. Right on the chart, at the top of that chart. It's where it is. All right. Times, now here's the next mistake. Delta S, I cannot use negative 326 because that's in joules per Kelvin, not kilojoules. So I'll convert him to kilojoules. Joules in the bottom, kilojoules in the top. 1 kilojoule contains 1,000 joules. So I remind myself that I'm dividing. I'm making it smaller. So he's going to be negative 0.3264 joules. All right, it's a negative. So he's negative 0.326 joules per Kelvin. Of course, the Kelvin cancels because this was in Kelvin over here, and leaves you. Kilojoules per Kelvin. Kelvin cancels. Do the math for that. What do you get for your delta G for this guy? Negative what? Kilojoules. Okay. If that's his answer, then is he spontaneous or not?
He is.
He is. He is. And that's all I can ask you. At that point, it's a final answer. By the way, if you do this whole guy again, and you will have to on the test, delta G of the reaction equals delta G of the products minus delta G of the reactants, you'll find that it doesn't take you very long to do it that way. Because products minus, here's your product. You'll have to look him up. But these guys are both going to be 0. That's going to be the free energy of that guy's going to be 0 anyway. So products minus reactants is going to give you a very simple answer. It should be very close. It may not be identical to, but very close to the number we just got down there. We didn't have time to do that today.
Phone.
Okay, we only have 10 minutes or so. Let's do the next guy. This is a longer one.
Yeah.
All right, it's the same, using the same equation, MC delta T, we used before, but putting them together. And I could have you solve for, in this case, I'm having you solve for the hardest one, I think, TF. Could also have you leave out one of the specific keys and have you solve for that. We did that in the lab back there as well. All right, so here's your equation.
Nice.
Here's your equation. Delta H lost plus delta H gained equals 0. And I need you to write that out, as well as spreading it out, MC delta T plus MC delta T equals 0. You spread this out, and you put the numbers underneath, and I'll tell you why. A lot of people are going to make a mistake in the actual algebra and math. If you remember the first time we did it, about half of both classes, I did this with you up to this point, next step. And then I said, okay, just do the algebra. And half the class got it wrong. So you want to show me these work, especially on this one, because there's a very good chance your algebra is going to be sketchy. All right, first of all, a guy who's losing energy. That would be the hot one. Which one was hot? 87.5 versus 20, the 87.51. That's going to be 12.3 grams of iron. So I'm dropping 12.3 grams of iron into cold water. I'm sorry, into cold water. And I'm going to see what happens. Try to figure out what the final temperature is going to be. Specific heat of water, I'm sorry, that's not water, but of the 12.3 grams iron, it's told to you, 0.444.